Okay, this is another example in the book of computing area or approximating area using the midpoint rule. So they give us this function f of x equals 2x minus x cubed, and they say find the area below this curve between 0 and 1, first using the midpoint rule with 4 rectangles. Okay, so roughly this is what the curve looks like. It's kind of a complicated curve, but just between 0 and 1, it's really the only place I'm interested in, so I just graph that portion of the curve. And of course here in red I drew in approximately what the rectangles that we're going to be using look like. Okay, so you can see that these 4 rectangles will pretty closely match the area below the curve. Okay, there may be a little bit of an overlap or underestimate in some places. Okay, but in any case, here's how we would do it. Okay, with 4 rectangles, we're taking that interval from 0 to 1 and chopping it into 4 pieces. So delta x, that's the width of each rectangle. Okay, it's going to be 1 minus 0, just the difference in my endpoints, divided by 4, since I'm using 4 rectangles. Okay, so that's 0.25. Okay, that means each one of these rectangles is going to be 0.25, or a quarter of a unit wide. Okay, that makes sense. The whole interval is 1 unit wide. We use 4 intervals, sub-intervals. They're going to have to be a quarter unit wide each. Okay. So it's kind of helpful to make this little table, because what we're going to be doing is we're going to use 4 rectangles. So my first rectangle lies above the sub-interval from 0 to 0.25. Now I need to find the midpoint of that sub-interval, because remember, that's where I get the height. Okay, so this first rectangle gets its height from the first midpoint. Well, if the left endpoint is 0, the right endpoint is 0.25, the midpoint is right in the middle. Okay, it's the average of those two numbers. So the first midpoint is 0.125. Okay, then my next rectangle lies between the x values of 0.25 and 0.5. I'm just moving another quarter of a unit to the right. Okay, this will be the midpoint, 0.375, and then I keep going, 2 more intervals, 0.5 to 0.75, midpoint of 0.625, and finally 0.75 to 1, and here's my midpoint there. Okay, so to get the area, it's a little bit of typing on the calculator. Basically, this is what you have to do, though. You have to put the first midpoint in the function, okay, and multiply it by the width, which is delta x. Okay, that'll give me the area of the first rectangle. Okay, and then I do the exact same thing for the second rectangle. I take its height times delta x, gives me the area. Same for the third rectangle and fourth rectangle. Okay, so it does take a little bit of typing. You might even choose to write some of this stuff down on the paper and do one thing at a time, but remember, for each of these function values I have to put those numbers into this function. Okay, so it does get to be a little bit of typing. But I did that on the calculator and I got about 0.7578 square units. Okay, if you look at the picture, I'd say that's pretty good. It's saying about 0.7576 square units. Okay, this box right here would be 1 square unit, so yeah, I'd say we're definitely a little bit less than a 1 square unit box here. So that looks pretty good. Okay, so what do we have? Okay, well, about 0.7578. Okay, well, what about the exact answer? Again, we can find that with integration, and I went ahead and found it here. I just integrate from 0 to 1, integrate the function 2x minus x cubed. Okay, and really this one wasn't too bad to find exactly. The antiderivative is 2x minus x to the 4th over 4, and then I substitute the endpoints in. Let's see, I get, that was a little typo from earlier. Okay, so I get, I put 1 into the antiderivative and subtract what I get when I put 0 in, and I get exactly 3/4 of a square unit, okay, which is, again, 0.75. So our estimate, which was 0.7578, was actually pretty close. Okay, the exact area is exactly 0.75 square units.